Good morning, CEO of Flights of Fancy. The purpose of this video is to present to you our team's design considerations and paper plane design. We define the best paper plane design as the one that can travel the furthest distance. The design must also be simple, not too complicated such that mistakes can be made in the process of folding. The plane must also have a stable frame such that it does not get disfigured easily due to external conditions which could affect its flight. We made some key assumptions in the choosing of the plane design. Firstly, we assumed that the air resistance was negligible. Air resistance depends on the object's speed and surface area. However, as the paper planes are of the same size, they would have the same surface area. They would be released with the same force as much as possible, which means their speed would not vary much either. Secondly, we assume that gravitational force is constant. Gravitational force on Earth is about 9.8 meters per second square and can vary based on location. However, as our experiment was conducted in the same location, gravitational force will be constant. Thirdly, we assume that all paper planes are the same as long as they are folded in the same way. No two things on Earth can be identical. However, we ensured only one person did the folding, as there would be a higher chance of the angle of folds being the same due to repetitive action. Fourthly, we assume that the thrower will be able to apply the same amount of force for every throw. Human error is inevitable and it is impossible to have the same amount of force applied behind every throw. However, this can be controlled by standardizing the angle of the throw and the physical position of the thrower. Hence, the force used can be negligible, as the difference can be reduced to a minimum such that it does not affect the results. To choose the best paper plane design, we decided to test out a few planes differing in the weight of the paper. The other variables that would affect experiment results were kept constant. Firstly, the design and measurements of the plane were kept constant because a difference in plane designs, wingspan or tail length can change the flying capacities of the plane. Secondly, the location which would affect the presence of wind was kept constant because the presence of wind can affect the stability and flight of the paper plane. Thirdly, the height and angle of the release of planes were kept constant. Height of release controls the air time of the paper plane, which will affect the distance travelled by it. Angle of release of the plane can affect the position of plane in the air and the direction of its flight. Fourthly, the thrower should be kept constant because different people can throw at different forces, and a difference in force will affect test results. Lastly, the number of times a plane has been thrown should be kept constant. A paper plane thrown more can have disfigurations which might affect the distance travelled by the plane since measurements are being altered. Here are our investigation and verification processes. A regression graph with an R-squared value closer to 1 shows that it passes through or is more proximate with most of the data points compared to the other two models. Hence, a best fit graph will have the highest R-squared value. After collating our results, a quadratic regression graph is the best fit to our experiment with the highest R-squared value of 0.892 when rounded to 3 significant figures. Our investigation has proven our hypothesis, the greater weight of the plane, the shorter the distance it can travel, to be wrong. According to the data, the distance traveled by the paper plane increases as weight increases, when the weight of the paper used is less than 72.8 GSM, whereas the distance traveled by the plane decreases as the weight increases, when the weight of the paper used is more than 72.8 GSM. Hence, we can come to the conclusion that the best plane design is one that is folded with a paper of grammage as close as possible to 72.8 GSM. Since it is hard to find paper of grammage 72.8 GSM, a paper of grammage 70 GSM will make the best choice since it can be more commonly available and can fly far at the same time.
Created using Powtoon.